I'm Anil Kumar. Welcome to my series on vectors. In this video, we have picked up few very good questions from previous test papers, and I hope solving those questions will help you to understand the topic better and even get a better marks. For example, the very first question related to tension in the string is right here from this particular test paper, right? So these are all very important questions which we cannot overlook. Now let's look into the concepts which we should know before getting into solution of each and every question here. The first one here is talking about tension in a string. So we'll make diagrams. Basically, you must have seen like this, just a reminder, right? So we'll be talking about what is the tension in these strings when some conditions are given to you, right? So that's the weight acting on it. Then we have equilibriant forces. Now, if there are more than two forces acting on a body, for example, we have a force acting kind of like this, right? Maybe some force acting in this direction. Then the equilibrium will be achieved if we have a resultant force and a force which is equivalent to that resultant force. And let's say in this particular diagram, we get some force which is kind of like this as the resultant force, right? Then the equilibriant force will be to keep this body in one particular position in equilibrium, which will be equivalent to this part, directly opposite to that force, and that is what we are looking for as equilibriant of the three forces, correct? Now when we talk about relative velocity, we are trying to sketch the position where we want to go, and let us say a flight example where the flight is trying to go in this particular direction, but there is some wind which is acting on it, and that pushes it somewhere else. And where does it land? It lands into a different area altogether. So there could be problems on how to correct the path or something like this, correct? And when we talk about the projection of vectors, then we are basically seeing if this is one vector, let us say, and the other vector is at an angle of theta, then the projection of vector is the cos component of that, right? So when you draw this, then this distance from here to here is the projection of the vector. Parallelogram and cross product algebra, basically whenever you find a cross product, you actually get the area of a two-dimensional figure, right? So if you have a parallelogram which is kind of like this, for example, in that case, the cross product actually gives you the height also, and that helps you to find the area. So if one vector is represented by one side, the other one as this will be angle theta. So this component is the height, which is b sine theta, correct? And therefore, A cross B actually gives you the area of parallelogram, which is magnitude of A times magnitude of B times sine of theta, correct? So we will be referring this to the absolute value, since the direction which is normal to this page is not part of the area, correct? Okay, so another formula to remember, let me also write down the dot product formula. A dot B is basically equal to magnitude of A times magnitude of B times cos of theta. And this formula will be used many times to find the angle theta itself, which is going to be, just rearrange this formula, right? So we get A dot B divided by magnitude of A times magnitude of B, correct? So a part of this formula also gives you the projection, which is right here. Combining these two components, we get the projection of A on B can be written as A dot B over the magnitude of B, right? So that gives you the projection Projection could be scalar and vector. So if we have a vector projection, right? So vector projection, this is scalar projection. In that case, the formula remains the same, right? And what you really do here is you multiply this by the direction, the unit direction, right? So again, we have B here divided by the magnitude of it, right? So that becomes the vector projection. As soon as you multiply by a unit vector in the direction, so once you find the scalar projection, you can find vector projection by multiplying by this, which is basically a unit vector. So let me write unit vector. In this case will be the vector B divided by the magnitude of vector B, right? So that becomes the unit vector. So with this, I think we should begin with our solution to these questions. I hope that is going to really help you to understand this topic better. Question number 2 here is, the dot product of vectors A and B with equal magnitude is 8. If the angle between them is 60 degrees, find the product of their magnitudes. So what we are given here is two different vectors, vector A, whose magnitude is, let's say, k, and vector B, whose magnitude is also k. The angle between these two vectors is 60 degrees, correct? We are also given that the dot product with equal magnitude is 8. We are given that the dot product of vector A with vector B is equal to 8, right? And we need to find the product of the magnitude. That means product of the magnitudes that means we need to find what is the product of these two, right? That is what we need to find. In our case, k square. That is what we need to find. Clear? So that is the part of question which we are trying to work out. Okay. So we are going to use the dot product formula to get the result. So we have A dot B equals to magnitude of A times magnitude of B times cos of theta. Now A dot B is given to us as 8. Magnitude is k, right? Let me write them in bracket now. Don't get confused with dot. Dot product is between vectors only. So we have cos of 60 degrees. We know cos 60 is what? Is half, right? So it is 8 into k square, and here we have half, correct? Now cross multiply, we get 16 equals to k square, and that is what we wanted to find, correct? So our answer is that the product of these two magnitudes, which in our case is k square, is equal to 16. Is that clear to you? Right? So that is how you are actually going to solve the question. Perfect. So let's move on and take the next question. The question here is, projection of vector A equals to pi plus j minus 4k on B, which is 2i plus 6j plus 3k, is 8 over 7. Find the value of P. So we are actually given the scalar projection of the vectors. Let us say this is one of our vectors. The other vector, let us say, is in this direction. In that case, the projection of vector A on B is given to us as 8 over 7, right? So this is the projection, which is the distance from this point to this point, correct? So we'll consider that to be the vector A and this to be vector B to solve the question. Now vector A projection on vector B basically means from here A dot B divided by the magnitude of B. Now how do we derive this? So there is a very short derivation. Let's look into this. It is dot product basically is magnitudes product times cosine of theta. So you can see from here that if angle is theta, then this side basically is A cos theta. So the projection here is basically magnitude of A cos theta, correct? So if I isolate that, I get what? I need to divide the dot product by the magnitude of B. Is that clear to you? So that is a simple derivation. Now here we are given that the projection, and whenever there is a number, we know it is scalar projection, correct? So the projection of A over B is this, and let's find the dot product now. So the vectors are these. Let's write their components. Their components are P 1 minus 4 dot, for B it is 263, correct, divided by the magnitude of B, which is 2 square plus 6 square plus 3 square, correct. So we get 8 over 7 equals to 2p plus 6 minus 12 divided by square root of 4 plus 36 plus 9. So that is 49. So we'll write this as 2p minus 6 divided by square root of 49. Now we can actually cross multiply, which this is 7, right? So it is square root of 49, let me write here, which is 7 over 8 over 7 is equals to 2p minus 6. And these two are simple, same things, so they cancel away. And what we get here is 8 plus 6 equals to 2p. 8 plus 6 is 14, right? So we can write this as equal to 14. And that gives you the answer P equals to 14 divided by 2, which is 7, right? So our answer is 7. Is that clear? P equals to 7. Correct. So that is how you're going to solve it. Now let's take up the next question. Question here is, determine the value of K such that the area of the parallelogram formed by the vectors A and B is square root of 41. So we are given the area itself. Area basically is equal to the cross product, right? So area magnitude is equal to magnitude of A cross B. That is what it is. So what we'll do here is that we'll find the cross product of these two vectors. So let's find what is the cross product of AB, right? Now we are given, which is, let's write it down. We have K plus 1, 1 and minus 2 cross K, 3 and 0, right? So that is what we need to figure out. So let's find the cross product. So IJK. We'll find the magnitude of this later. So we have K plus 1, 1 minus 2, and we have K3 and 0. Now that gives you I 0, and that minus 2 times this 6, right? Minus J, that is 0, and this gives you plus 2K. And plus K, which is 3 times this, which is 3K plus 3 minus K, right? So this gives you 6I minus 2KJ, K is a constant. And here you get 2K plus 3 as a component along Z direction. So that becomes your vector. Now, what is the magnitude of this? So the magnitude of A cross B is basically square root of 6 square plus 2K square. You may write minus, but that becomes positive, plus 2K plus 3 square, correct? Square root. So that is what it is. So now we can take it on the right side and kind of solve it. So let me write down this as 36 plus 4K square plus, when you open this, you get 4K square plus 2 times 2, 4 times 3, 12K plus 9, right? So let's write this as A cross B whole square, right? Will be all this. So what we can do now is equate the two, that is to say, what we have here is the cross product. So we can say that the A cross B whole square will be square root of 41 square, correct? So that is what we get. So we'll write this. 36 plus 9 is 45. So we have 45 k square and k square, 4 of them each, 8k square, and then we have 12k is equal to 41. Clear? So we can now solve this equation. So we have 8k square plus 12k plus 45 minus 41 equals to 0. So we get 8k square plus 12k plus 4 equals to 0. 4 is common, right? So we get 2k square plus 3 times k plus 1 equals to 0. Well, 2 times 1 is 3. You get 3 as a sum. So we could write this as 2k square plus 2k. Let's factor it, right? So what we have here is we can take 2k common. So we get k plus 1 plus, we already have k plus 1 here. K plus 1 is now common. Okay, so we can have 2k plus 1, correct? So, okay, so that is equal to 0. Now from here we get two solutions, and one is k equals to minus 1, the other one is k equals to minus half, correct? So these are the two values which will give you the area of square root 41. Is that clear to you? So that's how we'll solve. Now let's take the next question, which is Marcus is planning to fly to a town which is 1,000 kilometers due north of his present location. There is a 45 kilometers per hour wind blowing from north 30 degrees east. If his plane can travel 500 kilometers per hour, what direction should the pilot head to reach the destination? Okay, so let's sketch the scenario. Okay, everything is happening here, so let me do like this itself. So let's see, Marcus wants to fly to a town which is 1,000 kilometers due north, so he wants to go here. Okay. Now there is a 45 kilometers per hour wind blowing from, so when it is from, will end up here, north 30 degrees east. So in this way, right? So the wind is blowing here in this direction. Is it okay? So that is what the wind is blowing. So this angle here is 30 degrees. Does it make sense? So let's say the component which I've drawn is the wind component. Now the pilot surely will have to head in this direction. You see how we got a diagram? So it is much simpler if you could work it out the way I've shown here. And we want to figure out this angle theta. That's the question, correct? Let's write down the values which we have here. We are given that this is 1,000, that is in kilometers. As far as the velocities are concerned, plane can go at 500. So this is 500, and for the wind it is 45. Okay. So let's figure out this angle. So this is 30 degrees. So this angle is how much? 90 plus 60, correct? So this angle here is 90 plus 60, which is 150 degrees. Now we know these, so we could use sine law. Perfect. So in this particular triangle, we'll use sine law. Since we have this combination 500 and this, correct? And what we need to find is this angle theta. So we can write sine theta over the opposite side is 45. We are comparing the velocity diagram, okay? Is equal to sine of 150 over 500. Clear? That's simple. So we get sine theta equals to 45 over 500 times sine of 150 degrees. Clear? So let's use the calculator to find this answer. Okay, so we have 45 divided by 500, and we'll times that by sine of 150 degrees. We get 9 over 200. So theta is basically sine inverse of 9 over 200. So we do shift sine inverse of our answer, we get what? 2.579. So that is what we get, right? So that's our answer. So our answer is this angle here is 2.579. So we can say from north it is 2.5, you can write 6 also here. Now let me write 2.58 degrees east. Is that clear? Here is question number 3, which is based on 3 forces acting at a point, and we need to find what is their equilibrant force. So let us see how to solve such questions. A particle is acted upon by 3 forces, 20 newtons pulling east, 17 newtons pulling southwest, and 23 newtons pulling north. The equilibrant of these forces is what? That is what you need to figure out. Now, what is the meaning of equilibrant? That means a force which acts in the reverse direction to make it stable. So that is kind of important to understand, right? We don't want the resultant force, okay? Let's look into the diagram. So let's say these are the 3 forces. We should have drawn the axis kind of like this. Okay. So what I'm trying to say here is a force of 20 Newton pulling east, right? So this is east direction. We are saying 20 newtons pulling east. And then we have another force which is 17 newtons pulling southwest, right? So this is, let us say, southwest for us. And then we have the third force which is acting north, 23 newtons. Let's say that is our 23 newtons. Correct? So what we are going to do, we'll write here force 1 which is 20 newtons, force 2 which is 17 newtons, and the force 3 which is 23 newtons. The angle with the horizontal here will be 45 degrees. Clear? Now let's write down all these forces in terms of their x and y components. So our step will be to write them in components. So we can say that F1 is, let's say this is along direction I and this is J for us. And the other force F2 will resolve in both the directions with 45 degrees, right? So force 1 is given to us as, let's say, 20I, right? Plus 0J. Force 2, which is this one, cos of 45. You know, cos of 45 degrees is 1 over square root 2. And sine of 45 is also same. Let me write down. Correct? So here, this will be 17 over square root 2 I. Since it is acting in negative direction, we have to write negative here, right? Similarly, the other one, which we are going to split this as, will be in this direction, correct? Now, if I say this is 45 degrees, that becomes the sine component. But anyway, magnitude is minus 17 over square root of 2j. So I and j are unit components, unit directions, x and y directions, right? Unit vectors. F3 is north, which will take as j. So 0 along I plus 23 along j. Is that clear? So that is how we could resolve them into our components. So if I combine all of them, so the net force Fn will be F1 plus F2 plus F3. Clear? So these are vector forces. So the net force will be how much? Let's combine them. So I components are 20 minus 17 over square root 2, right? That is your I component. Plus j components are how much? 23 minus 17 over square root 2. Clear? So that becomes your net force. We can use calculator to find this value. Let's do it. So we have 20 minus 17 divided by square root 2, which is equal to, in decimals, 7.979. So let me just write, okay, 7. We are using calculator, so no problem. I, right? And then we have 23 minus 17 divided by square root 2. That in decimals is 10.979. Okay. J. So that is your force. Now we could write this also as magnitude and direction, right? So we got the force now. So let me write down. We say the force acting upon the resultant force is basically 7.979 I plus 10.979 J, right? That is our resultant. Now this is basically resultant force. So what is going to be the equilibrant force? So what we really found here, let's try to understand this situation, right? So we are saying that the resultant force for us is, let's say, 8 units in this direction, 10 units in that direction, right? So 8 and 10, kind of like this. That is the resultant force we are talking about. That is F of n. But what are we asking for? We are asking for equilibrant force. So that equilibrant force will be acting in the reverse direction. You get my point. So that is your force, which is equilibrant force. This is what we need to find. So it is acting in the reverse direction. So you could show it like this. Is that okay? Now, let's first find the angle theta here, which the resultant makes, and also the magnitude. So what is the magnitude of this force? So the magnitude of this force is square root of 7.979 square plus 10.979 square. So we get square root of 7.979 square plus 10.979 square. So that is equal to 13.57. Newton, right? So let's write the magnitude of this force as 13.6 newtons. Is that okay? Now let's also find the angle tan theta. So tan theta will be a ratio of 10.979 over 7.979. So angle theta will be tan inverse of, let me write 10 over 8, okay. So we get shift tan inverse of 10 divided by 8, which is, 11 divided, I'm so sorry. 10.9 is 11, right? Okay. Okay, let's delete. Let's write the whole thing. 10.979 doesn't take time, right? Using calculator. 7.979 is equal to 53.99. So that is 54 degrees. That's good. Okay. So we got this angle theta as 54 degrees. You understand? So that really means that this angle here is also 54 degrees. Now tell me, what should be the equilibrant force? Right. So as far as the vector value is concerned, it will be negative of f of n, right? So let me write down in this thing. So equilibrant force will be negative of f of n. That is clear. The magnitude of this equilibrant force, however, because magnitude is always a positive quantity, will be 13 point, we'll round this to 6 newtons, right? And the angle theta will be what? So the angle normally should be given from the north. But you could also give from south, right? You could give this angle also. Is it okay? So this much is how much? 90 minus 54, right? So 90 minus 54 basically is 36. So this angle here is 36. So you could give the angle from south. This is south, this is north, correct? And that is west. So from south, 36 degrees west. Is that clear to you? So that is how you're going to answer this particular question and write your values. Is that clear? Perfect. So I hope the solution is absolutely clear. So whenever you're working with more than two forces, it is always a good idea to write them in the component forms as we did. Adding and subtracting components is very simple. Get the resultant and then find the magnitude and direction. If you need to write the equilibrant force, then it is always acting in the reverse direction. Note that, right? And clearly work out the angles again and then write your answer as we did here. I hope that helps. The question here is, a 15 kg mass is suspended from a ceiling by two hooks 25 centimeter apart. The mass is attached to the hooks by two pieces of strings, one 15 centimeter and the other 20 centimeter in length. Find the tension in each string. Include a position diagram and a vector diagram with your solution. I would like you to pause the video, answer this question, and then look into my suggestions. Now let's begin with what is given to us. So we have a ceiling here. So let me sketch the diagram. Now in this ceiling is given to us as what, two hooks, and from these two hooks we have two strings. So these strings are 15 and 20 centimeter long, right? So we'll make one smaller, right? The other one longer. Okay. So these are the two strings. Now from these two strings, we do have a mass holding, kind of like this. Okay. Now the tension, because of this, will be in the direction, and the mass has weight, which is kind of a force, which will act downwards. Correct? So we have here all the things mentioned. Now this is which kind of a diagram? Is it a position diagram or a vector diagram? Now that actually gives you the position of each and everything as explained in the particular question. Is that clear? Right? Now to complete this position diagram, let me write down here. This is position diagram. Now, to complete this position diagram, we need to fill in all the values, correct? So we only know the three sides actually. This is 25 centimeters, the distance between the two hooks, and the length of the strings, which is 15 and 20 centimeters, right? So all units are in centimeters. Okay. The mass given to us is 15 kg. So this force which acts here will be 15 times 9.8 kg weight, or we can write newtons, right? So that is it. We still need to find the angles to complete our diagram. Is that clear? Now since we have three sides, right? So it is side, side, side. That means we could use cosine law, right? So we'll use cosine law to find the angles. Let's call these angles as alpha and beta. Okay, so what is cos alpha? So cos alpha will be, you have to add the squares of these two sides which are adjacent to it, right? SAS, these two sides. So which we get 25 square plus 15 square, and take away the other side which is far away. That's a very easy way to remember, right? And you have to, of course, divide by these two sides, which is 25 times 15. You get cos alpha. Similarly, we'll calculate cos of beta, which is going to be this angle. So these two sides this time. So we'll do 25 square plus 20 square minus the far away side, which is 15 square, divided by 2 times 25 times 20. Now, cosine law is used in two cases. One is when you have all the three sides given. The other one when you have included angle. So this formula is kind of used for included angle. We'll kind of inverse and later find out the angle. So that helps you, right? So now let's just calculate. So if we have 25 square plus 15 square minus 20 square equals to, divided by, within brackets, 2 times 25 times 15 bracket close equals to, we get 3 over 5. We'll just do cos inverse of this. So we get alpha equals to cos inverse of 3 over 5. Correct? So we'll do shift cos inverse of our answer, which is 51.13 or 53.13, right? So we can actually round it to 53.1 degrees. Correct? Now let's find beta. So we'll do 25 square plus 20 square minus 15 square equals to, and we're going to divide this number, which is 800, by 2 times 25 times 20, right? So that gives you 4 over 5. So beta is cos inverse of 4 over 5, which is how much? Shift cos inverse 4 divided by 5 bracket close equals 2. This gives you 36.869. So I'll write this as rounded to one decimal place. I'll write this as 36.9 degrees. Is that clear? So now we got these two angles, and we can write these angles as, let me take a different ink. Okay, this is okay. So we get these alpha as 53 degrees, okay, 0.1 degrees, and beta here is 36.9. Okay. So now our position diagram is complete. Correct? So first part we have done, and that is by finding these things, we actually got our position diagram. Now let's work on the vector diagram. So how do you get the vector diagram? Let me also multiply 15 times 9.8, which gives us 147. Okay. So this value is 147 newtons. So to draw the vector diagram, you need to understand that these are the two tensions. Let's call them as tension 1 and tension 2. Now the body here is at rest. That means this component of weight is in equilibrium and there is an opposite, equal and opposite force acting on it. Correct? So this equal and opposite force can be represented by the vector, which is equal to 147 newtons. Right? Now, let's look into the tension 1, this one, right? So what we need to do, like in vectors, we'll just translate this vector right there, right? So parallel to this, so we'll translate this vector parallel to this. Do you see that? Parallel to this. Now clearly with the horizontal, what is the angle this is making? With the horizontal, this vector is making an angle of 53.1. Correct? Now from this point, we'll now draw a vector which is going to be parallel to this, and you'll see that it will match up with your resultant, right? So that is the equilibrant course, right? So it brings, this is the force which acts in the opposite direction to the net force which you see here, and so it is in equilibrium, right? Now, the angle here is this angle, which is 36.9 degrees. Is that clear? Okay. So that is how you actually get your vector diagram. So let me write down, this one is your vector diagram. And let me label this at tension 1, tension 2, and that is our equilibrium force, right? Now, let's calculate the tensions in each string, correct? Since we know our angles, we know this angle also, right? Okay, let's add these two first, these two angles. That is the right angle, correct? Okay. So the angles in this corner here are basically 53.1 plus 36.9, right? So that gives us 0, 1. So 7 and 3, 10, and 1, 4 and 5, 9. So that gives you 90 degrees in this particular case. Correct? So we get 90 degrees as a total angle at this point. We can actually find these angles also. This angle will be, now this is a straight line, this angle will be 90 minus 53.1, correct? So let's write down this angle. Since we need to know those angles to use sine law and get T1 and T2 values, correct? So 90 minus 53.1 gives us a value of 36.9, obviously. Correct? So you know this angle here is actually 53.1 degrees, correct? Okay. Now once we know the angles in our vector diagram, we can actually apply the sine law to calculate tensions T1 and T2, right? So T1, this T1 is equivalent to what? You can look into the side which is opposite to T1, and that side has an angle which is 90 degrees here. So basically it's a 90 degrees triangle. So you could use sine law, cosine law, or you could straight away write down your results. Because this is a 90 degrees, we can easily write down the results based on the hypotenuse, right? So let me mention here. So our method is slightly different, easier. We have an easier option. Since we have a right triangle. Do you see that? Since that angle is 90 degrees, correct? So think like this. What triangle we have here? Otherwise we'll use sine law, correct? Okay. So that's our triangle, correct? Now in this triangle, what you notice here is this side is 147, correct? Now this angle is 90 degrees. One of these sides tension is T1, the other one is T2. And the angle here, we'll consider that angle, 2p 36.9. Is that clear to you? Why am I drawing it? Since we found this to be 90 degrees, we need not use sine law. That's what I want to stress on. Does it make sense to you? Right? So from here, we can clearly write that sine of 36.9 degrees is equal to T2 over 147, and that means T2 is equal to 147 times sine of 36.9 degrees. Is it okay? Similarly, we can write here that cos of 36.9 degrees is equal to T1 over 147, and that implies that T1 is equals to 147 cos of 36.9 degrees. Is that clear? So let's figure it out. So we have 147 times sine of 36.9, which gives us one answer, which is 88.26. Let's call it 3, right? Newtons. And the other one is 147 times cos of 36.9, which is equal to 117 let's say 6 newtons. Does make sense? Correct? Now that is how we will do if we have found that the angle is 90 degrees. Else, let me write alternate, use sine law. Here also you could have used sine law, no problems. But I hope you understand and appreciate how do we draw a position diagram, how do we draw a vector diagram, and solve to get the tensions when all the lengths are given to us to start with and the mass of the object. Always remember that mass of the object has to be multiplied by the gravitational force to give you the net force acting downwards vertically. Right? That's what we did here. I have taken 8 questions from previous test papers. These are all multiple choice or objective type questions. They are based on dot product and cross product applications. Question number 1. If magnitude of vector A is 3 and magnitude of vector B is 4 and the angle between these two vectors is 60 degrees, numerical value of this is what? So let's figure this out. So we can just expand this, right? Do the dot product. So we get 2. A dot A will be, or let's write down 2A dot A. We have space here. Minus 2 times 3, 6 A dot B. Then we have B dot A. We can also write this A dot B since dot product is commutative, right? And here we get minus 3 B dot B. Now A dot A is the magnitude of A whole square minus 6 times A dot B, and plus we could have combined them. So that gives me 5 times A dot B, correct? And this is minus 3 times magnitude of B square. Now you are given the information to find the dot product. So we can do that on the side. What is A dot B equals to? So A and B magnitudes are given to us. We can calculate this on the side. We say A dot B is basically magnitude of A times magnitude of B times cos of the angle between them, which is 60 degrees, right? So 3 times 4 times cos of 60 degrees, and cos of 60 degrees is half, right? So that gives you equal to 3 times 4, 12, and half will be 6, correct? So A dot B is 6 for you. Now we can place these values here and find the answer. So 2 times square of 3 minus 5 times 6 minus 3 times square of 4. Okay. So that is 9 times 2, 18, minus 30, minus 16 times 3, 48. Right? So from 48, when you take away 18, you get what? You get 30, and minus 30 will give you minus 60. So option B is the right option, correct? Question 2. A stove is pushed 3 meters across the floor against a frictional force of 200 newtons. Find the work done. Now here the key word is against the frictional force, right? So we get a negative answer, and it is the product of these two, which is the dot product, right? So it is 200 times 3 Newton meters or joules, right? Which is 600 Newton meters, correct? Question number 3. Suppose x dot y equals to 2 magnitude of x is 2, magnitude of y is square root 2. What is the angle between the two vectors? So x dot y is basically magnitude of x times magnitude of y times cos theta, correct? Now we're given all this, we need to find the angle between the vectors. So we know cos theta is basically equal to x dot y over magnitudes product, right? So let's calculate. So we have the value as 2 for the dot product, and these magnitudes are given to us as 2 and square root 2, 2 and square root of 2, right? So what we get, cos theta as equals to 1 over square root 2. So that implies that theta equals to 45 degrees, clear? So B is the right option. Now, what is the dot product of these two? So let's do the dot product. We have 4 minus 10, 3 dot of 1, 1, 5, correct? So 4 times 1 is 4, minus 10 and 3 times 5, 15 with a positive sign. So what you get here is 5, you get, when you take away 10 from this, you get 5, 5 plus 4 is 9 for you, right? So 9 is there. So that becomes your correct answer, clear? Question number 5. If the vector A is 1, 0, minus 4 and B is 5, 2, 1, what is the scalar projection of A on B? We need scalar projection, right? Just the magnitude. So scalar projection of A on B is basically A dot B divided by the magnitude of B, right? That is what it is. So we are given these two vectors. Let's find the dot product. 5, 2, 1 divided by the magnitude of B, which is square root of 5 square plus 2 square plus 1. So which is 5 plus 0 minus 4 over 25 and 4, 29 and 1 square root of 30. Correct? So we get 5 minus 4 as 1, so that becomes our answer. Correct? So that is how we are going to answer this particular question, right? Sixth question here is, for the vector A and B, what is the vector projection of A on B? Now, what is the formula for vector projection? So when you have vector projection, then we are also looking into the direction, right? So it is in the direction of B. So this time, be A dot B over magnitude of B, right, square times the vector B. So basically a unit vector B we are looking into. Is that okay? Now, let's do the dot product. Minus 340 dot 214, and the magnitude of B will be square. So that means we have 2 square plus 1 square plus 4 square, right? And the vector B, which is 214. Correct? So that gives us, this is the scalar multiple, right? So what we get here is minus 6 and 4 plus 4, right? So that is over this magnitude, which is 4 plus 1, 5, and 16 is 21. And that is the vector 214. Correct? So we get here, when you take away 6, you get minus 2 over 21 and 214. So we get the option A as our option. Is that okay? So we get A as our option. Correct? Let's move on and take the next question, number 7. For the vectors A and B, what is the cross product, right? So let's find the cross product, A cross B. You can use the matrix form. So you can IJK. A is 4, minus 6, 10, minus 6, 9, minus 15, correct? So we get I, that gives you 90, right, with a positive sign, minus 90, so that is 0, minus J, So 4 times 15, 60 with a negative sign, and that gives you negative of this, which is again 60 with a positive sign now, plus k, which is 4 times 9, 36, minus 36. So that is 0, 0, 0. That is your vector, right? So that is your answer. Now, question number 8 here actually is a true or false question. You need to justify your answer. State whether each statement is true or false, assuming all the vectors are non-zero vectors. For each statement, justify your choice. The very first one is, if sum of 3 vectors is equal to 0 vector, right, then A, B and C must be collinear. Well, not necessary, so the answer will be definitely false. Let me write down here false. Okay, and the reason could be, see, if I have this, right, then we have zero sum, correct? And they are not collinear, correct? So they are not collinear. B, if two vectors A and B are collinear, then the dot product is 0. Well, this is also false. If they are collinear, means if they are the same direction, then it's not 0. It is 0 when they are perpendicular, right? So because cos theta is 0 for this. So it is 0 for 90 degrees. 0 when perpendicular. Clear? C. If C equals to this represents A cross B, and D is negative of this represents B cross A. That is true, right? Because A cross B and B cross A, they are negative of one another, right? So that is true because B cross A is equal to negative of A cross B, right? Therefore it is true. Now we have B cross A cross C, there is nothing in between, it represents a vector value. Well, this is not valid, false. It is not valid. Since you know what, we don't have a dot or a cross product, and this D could have been a scalar, right? So you cannot just multiply like this with a vector, right? So it is not permitted. Not permitted. Clear? The last question here is, if A is this and A dot A is how much? Well, A dot A is how much? A dot A is magnitude of A square. This is square root, right? That doesn't work. So basically A dot A will be equal to square root of 1 square plus 2 square plus 3 square, which is 14. So this one is also false. Clear? So A dot A is not square root 14, but it is 14. So this is the last question. It's based on the algebra of cross products. We need to prove that 2V minus W cross 3V minus W is the cross product of V and W. So let's do our math. We have 2V minus W. V and W are vectors, and we want to do cross product with 3V minus W, correct? So it'll be giving you 2V cross 3V, right, minus 2V cross, W, and then with W we get minus W cross 3V, and that becomes plus W cross W. Now, as you know, the cross product, let's write A cross A. So if I write A cross B, we know A cross B is magnitude of A times magnitude of B times sine theta. But if we are writing A cross A, then it will be magnitude of A times magnitude of A itself times sine of 0, right? Since both are in the same direction. So that is going to be 0. So this here will be 0 for us. And here also we are doing v cross v. So let me go one more step here. We get 6 v cross v. And here we get minus 2v cross w. Here we have minus 3 w cross v. And here we have w cross w. Now v cross v and w cross w will be zeros, right? So this is 0. And here we get minus 2 v cross w. Now we need v cross w, so we'll swap this, right? So when you swap this, the sign changes. So we get 3 times v cross w. That is 0. And when you combine these two, you get v cross w, right? And that is what we wanted to prove. So we began with the left side and we showed that it is equal to the right side. Perfect. So that is how actually you can prove this particular thing. So I hope with this you understand how we could solve all these questions. So that brings to the end of our video. You have understood what all we did here. The questions were actually selected at, the right ones were selected, and we took them not in any specific order. So don't bother about the question numbers which were there. Look into the contents. I hope that should help you. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.